Now let's look at this question of what a conceptual architecture actually is. The conceptual architecture, in a very brief summary, is a model of the solution to a problem without considering any constraints of the system. So we assume instantaneous response. We assume that there's no limits on memory. We assume that there are no problems with scalability. We can throw as many instances in it as we want and it will all happen. So we're simply trying to model the solution or our proposed system as a pure theoretical construct without regard to the practicalities of trying to implement this on some actual pieces of hardware. So that's a conceptual model. Its sole purpose is to find out, do we have the elements we need to provide a solution to this problem? Now, by a solution to the problem, one thing that I haven't put into this particular topic is modeling the problem in the first place, and that's because the model of the problem could be something that's done in Petri nets, which you can use for software architecture as well. Or it could be done in something like BPMN, a business process modeling language. Now, there isn't a direct translation from business process models through to object-oriented models, and there'd have to be some translations, and you're dealing with a system of which the computer system is a part, not the whole. Whereas what I want to deal with in conceptual architecture is only that part of the solution that exists or will exist on the computer. And before we get to putting it on the computer, I need to model that part that we're interested in and see whether it works or not, and whether it provides the required functionality. So that's the conceptual architecture. But knowing that doesn't tell me how to design one. I could say, well, knowing that I need to design a building doesn't tell me how to design a building. What kind of a building is it? What is it supposed to do? And the important thing about a building or the architecture of anything is what's going on. What's happening within it? The building doesn't exist for people to just go and admire, with the possible exception of the pyramids of Egypt or something of that nature. But even there, the whole purpose was to entomb somebody and to celebrate their life and their importance. But let's get back to realistic things. Most buildings exist to support a range of activities in a range of circumstances. Now, software architecture is no different. The architecture exists to support a range of activities in a range of circumstances. Now, those activities are usually the moving about of information or the control of a real-time system or something of that nature, right? But it really is the activities of the system. And the range of circumstances can be not only the happy case where everything's going right, but all the exceptions that could occur and the strange circumstances that could occur, as well as the likely future changes. Now, that's pretty important for software architecture, just as it is with a building. You can put up a building in such a fashion that its future uses includes renovation and change. But the system itself is almost a living entity. The system itself has to support the range of activities. Obviously, it doesn't dynamically change of itself, but it can respond, or it can support a response to a stimulus. For example, a hacker attack is a stimulus, and the system architecture can enable and support a response to that. But a poor architecture could inhibit a response to a hacker attack and actually support hackers. So we are talking about something that does participate in the responses and activities of the system that's running within the architecture. And the point about putting up a jellyfish there is that jellyfishes don't have a brain, and they're not even a single entity. Most jellyfish are made up of about 4 different animals, and they kind of cooperate and get things done, and as I say, without a lot of intelligence. So there's a conceptual architecture. It's a model of the proposed solution without considering any practical constraints.